All right, so we're gonna solve a new kind of equation. We're just gonna see this for like a second, and then we'll sort of put it away for later. But it's called a rational equation, and it's called a rational equation because they all depend on they have fractions in them, and more than that, you've seen equations with fractions before. Those don't count as rational equations. In order to count as a rational equation, it's got to have a fraction in it that has some sort of variable in the denominator. That's what makes them special. That's what makes them rational equations. Now, you haven't seen these kinds of equations before. The most similar thing you've seen are simply linear equations with fractions in them. If you recall, the thing to do with those kinds of equations, those equations with fractions in them, is first to get rid of all the fractions by finding the least common denominator and multiplying every term by that least common denominator. So for example, this equation, x over 3 plus 4 equals 1/6, it's got a fraction because you got the x over 3 in there and that 1 over 6 in there. But you don't want those fractions to be there. So what is our least common denominator for this equation? 6, yeah. 3 goes into 6, 6 goes into 6. That's the lowest number that does that. So we're going to multiply every term by 6. And you can use 6 over 1 if that makes you more comfortable when you're dealing with a fraction. So x over 3. Okay. And we're going to multiply that by 6. In the form of, I guess, in this case, 6 over 1. Okay, then we're going to have plus. We're going to multiply the 4 by 6 as well. We're going to have 6 times 4. And there's an equal sign. And then we're going to multiply this last term by 6 as well. 6 over 1 times the 1 over 6 that is there. Okay, so if we simplify this, well, if we multiply these products together, that first term will be 6x over 3 plus 24 is equal to 6 over 6. Now it looks like there's still fractions there, but the thing is now that they've been multiplied by the least common denominator, the fractions will reduce to whole numbers. For example, what's 6 over 3? 2. So this is simply 2x plus 24. And what's 6 over 6? 1. So it just becomes the equation 2x plus 24 equals 1. After which, this is like a regular linear equation, and you can solve this normally. Just divide by 24 on both sides. Or sorry, subtract 24 on both sides, and then divide by 2. And you'll get x equals negative 23 over 2. But you've got your solution there. Okay, and we're going to do a similar thing here. We're going to be finding the least common denominators for these various, rational equations that you see down here. You'll notice that some of these denominators include factors. But before that, we're going to talk about restricted values. Okay, so Did anyone ever tell you in the past about trying to divide by 0? Is it something that you can do? No. Well, if you divide 0 by anything, it is 0. But if you try to divide a number by 0, let's just say, like, I don't know, 5 divided by 0. That's not a thing. That's not an operation that you can do. And that has to do with the fact of, like, what division is. I mean, in a way, you know, 5 over 2, for example, is like, what if you had 5 things and you wanted to divide it into 2 groups? Each group would have 2.5. You know, 9 divided by 4. Well, if you have 9 things and you try to divide them into 4 groups, you know, maybe you have to slice one of them up, but into 4 equal groups of 2.25. You know, you can split those 9 things or whatever. So it doesn't make sense to say that you're going to try to divide by 0, to say that you're going to try to take something and divide it into 0 equal parts. And so how big is each part? That doesn't really make sense. So you just can't divide by 0. And just remember that, because it's going to come up repeatedly. The fact that division by 0 is not something that is allowed. Okay. So because you cannot divide by 0, and in a fraction or a rational expression, the number, you know, the whatever is on the bottom is what you're dividing by. So for example, in this first expression, you're taking 4 and you're dividing it by 7x. Because you can't divide by 0, that denominator should not be 0. It should not be 0 ever. Because if it was, there you are dividing by 0. So the denominator cannot equal 0. Any value of x, because these do have variables in the denominator, or any value of a variable that makes the denominator 0 is called a restricted value, because it just can't be that value. Because if it was, you'd be dividing by 0. Okay. So we're only going to pay attention to the denominators for this part, because that's all we care about. All we care about is the denominator not being 0. So if you have a highlighter, go ahead and highlight each sort of factor. Well, sure. Or just every denominator, I guess. Okay. So if your denominator is 7x, what is your restricted value? What value of x would make that denominator 0? Yeah. If x was 0, well, 7 times 0 is 0. That would be 4 divided by 0. That's what you want to keep from. Not yet. Okay. And you can actually do this in a sort of, you know, you don't just have to like look at it and be able to tell. You can say, this denominator, I don't want it to be equal to 0. So, you know, treat it like an equation, but use a do not equal sign. And if you do that, then, whoops, 0. Yeah. You can get that the restricted value is x equals 0. Okay. If your denominator is x plus 2, what value of x would make that denominator 0? Yeah, if you imagine placing negative 2 right where that x is, the negative 2 plus 2 would cancel out, become 0. That's what you want to stay away from. And you can do this in much the same way. You can say that denominator of x plus 2, I don't want it to be 0. And then just subtract 2 from both sides of this on equation. And you can get that x should not be negative 2. That's the restricted value. How many of these are there? Okay, that's not too bad, I guess. Here, the denominator contains two different factors. One of the factors it contains is y minus 3, and the other factor it contains is y plus 4. So how many restricted values do you think there are going to be for this expression? Two, right? What's one of them? Okay, y shouldn't be 3. And what's the other one? Y shouldn't be negative 4. I mean, you could go through the trouble of saying y minus 3 does not equal 0, and then, but you can sort of tell. It's very much like finding the solutions to a quadratic equation or a linear equation. In fact, here is one right now. Here's one that you're actually going to have to factor. So x squared minus 3x plus minus 10 is here. And so just looking at x squared minus 3x minus 10, it's not immediately obvious like what values are going to make that 0. But if you were to rewrite this with the denominator all factored out, what two factors would have to be there, that multiply to negative 10 and add up to negative 3? Okay, minus 5 and plus 2. This is just a sort of regular one. So this will be x minus 5 and x plus 2 on the bottom. And that is still your denominator, just factored out. And so there's going to be two restrictive values for this as well. What's one of them? Okay, 5. And the other one is negative 2. Okay, now this last one, you got x squared in the denominator. What value of x, if you plugged it into there? Yeah, just 0. I mean, it doesn't matter that it's x squared. It could be x squared, x cubed. But like, if you put 0 into there, regardless of what power is actually on it, that is going to be 0. So x shouldn't be 0. I mean, you can still do that like the usual way. You can say x squared shouldn't be 0. Take the square root of both sides. And then you get x, shouldn't be 0. So every rational expression, every rational equation is going to have these restricted values. But it's usually not going to be a huge amount of trouble to find out what they are. Because they're all going to be based around what are your denominators. So in example 4, there's only one. What is the one restricted value for x? 5, right? Because that x minus 5 in those denominators. So just sort of off to the side, right, x shouldn't be 5. And just keep that in mind. And the reason that we want to keep this in mind is because once we solve this, we're going to get an answer for x. And it's possible that that answer is going to be something called an extraneous solution. It's something that appears to be an answer, but is not actually, does not actually turn out to work when you plug it back into the original equation. Yeah. So we want to make sure that we don't get 5 as our solution. And at this point, we're just going to solve this like any other sort of problem with fractions. What is the least common denominator in this problem? Yeah. At this stage, least common denominators don't have to be just numbers anymore. They can be entire expressions or, combinations of factors. Here, you got x minus 5 in the denominator here and x minus 5 in the denominator here. It's actually your only denominator. but your least common denominator is going to be the entire factor x minus 5. So every term, just like with the with this problem up here, every term we're going to multiply by x minus 5. Okay, so write the terms exactly as they were. Except I'm going to multiply them by x minus 5. And you can have x minus 5 over 1 if that sort of makes you more comfortable. Equal sign 14 over x minus 5 multiplied by x minus 5 over 1. Now, before you go around distributing things, the whole point of multiplying by a least common denominator like this is to make sure that the equation no longer has any fraction bits in it. In this first term, do you see anything that will immediately cancel out? Right, so you got an x minus 5 on the top and an x minus 5 on the bottom, so they should cancel out with each other immediately. Don't try to multiply the 4x times x minus 5 and, it's easier now just to see, hey, if you see them being multiplied together and you got a thing on the top and a thing on the bottom, to have them cancel out with each other. Is there anywhere else where this same thing happens? Right, over on the right side, you got x minus 5 on the top and the bottom. They cancel out with each other. So all we have left is 4x over 1. We can just write that as 4x minus 1 times x minus 5. You can go ahead and distribute that if you want, but that equals 14. Okay. And if you go ahead and distribute that, that's going to be 4x minus x plus 5 equals 14. Which just looks like a regular linear equation at this point. Okay, so say 3x plus 5 equals 14. Subtract 5. 3x equals 9. So what is our proposed solution for x? Right. And the reason that I said proposed solution is we still have to check whether the solution that we got is extraneous or not. Is x equals 3 our restricted value from the beginning? No, so it's okay. And so that is the solution, and if we were to plug it back in, it would work. Okay. All right. This is not the restricted value. Okay. In example 5, what's our restricted value?
3.
Right? Positive 3 coming from that denominator of x minus 3. Oops, 3. Yeah. Okay. And what is our least common denominator? Right, that factor that's on the bottom there, x minus 3. So every term, each one of these three terms, we're going to multiply by x minus 3. So 7 over x minus 3, we're going to take that and multiply it by x minus 3. For this one, maybe x minus 3 over 1. There's an equal sign. Then the term 3 over x minus 3, we're going to take that and also multiply it by x minus 3 over 1. And then this minus 2, we're also going to multiply by x minus 3. Although we can just use a regular x minus 3 here. What will cancel out immediately? Right, all those x minus 3, those pairs of x minus 3s, where one's on top and one's on bottom. Okay, so all that's left is 7 over 1, which is 7, equals 3 over 1, which is 3, minus 2 times x minus 3. If you go ahead and distribute that minus 2, making sure to distribute the minus with it, you'll get the equation 7 equals 3 minus 2x plus 6. You can combine the 3 and the 6 to be 9. 7 equals 9 minus 2x. Maybe subtract 9 from both sides. Negative 2 equals negative 2x. I mean, there are a lot of ways to do this, but you're going to end up with x equals 1. Now again, this is only, that x equals 1 is only a proposed solution right now, because we still haven't checked it against the restricted value. Is x equals 1 that restricted value from the beginning? No. So this is okay, this is good to go. This is not the restricted value. Let me look at the other ones here. Okay. That's fine, that's fine. Yeah. X minus 3x. So 2x. 6. That's fine. Okay, I think we can probably skip number 6. Let me just check real quick. Okay, we shouldn't skip that one. Okay, what's the restricted value in example 6? 1, right? So we don't want our solution to be 1. Now what's the LCD? Right, that factor of x minus 1, that's that's down there. So every term will multiply by x minus 1. So we'll have 8x over x minus 1. We'll multiply that by x minus 1. We'll have an equal sign. We'll have an 8 over x minus 1. And we'll multiply that by x minus 1, since that's our least common denominator. And this negative 4 will also multiply by x minus 1. Now it's going to cancel out every fraction. So we're left with 8x over 1, which is just 8x, and 8 over 1, which is just 8. So we're just going to have 8x equals 8 minus, and I actually am going to do that in one step now. If we distribute that minus 4, that's going to be 8 minus 4x plus 4. Okay. If I just continue this over here because I'm running out of space, 8x is going to equal, combining the like terms, 8 and 4, that's going to give 12 minus 4x. Adding 4x to both sides, that gives 12x equals 12. So what is x? Okay. But is it really though? Because yeah, if we check it against the restricted value from the beginning, x shouldn't be 1. So that's not going to work, and you can see it's not going to work because if you try to plug in x, because like x equals 1 is sort of being touted as a solution here, but if you actually try to plug it in for x into the original equation, you can't do it. You get what, 8 divided by 0 equals 8 divided by 0 minus 4, and that just doesn't make sense to try to do. So this is an extraneous solution. And because it was our only proposed solution, and that one turned out to be extraneous, do we have any other solutions? No. So this problem, this example, has no solution. There's no value of x that's going to make this true. There's all this space on the bottom of the second page. You think they could have spread these out a little more. I mean, I guess I technically... Yeah. Okay. Something happened and I'm not, that's fine. I'll just write it again. And so for this one, there is no solution.
I have a question.
Mm-hmm.
So, what if like the what's it called? The value, the restricted value?
Right.
If it was like x plus 1, would that be like x can't equal negative 1?
Yeah. It's always just going to sort of look like the opposite of whatever it kind of looks like. Kind of the same as when you're like factoring and trying to find solutions. It's always going to be the opposite to what number is attached to the x on the factor. Yeah. Yeah. And here we got a couple more. We'll probably do like 2 of these. Now that we have seen one where, you know, you get an extraneous solution and there is none. Okay. So depending on the number of different factors you have, you know, in your denominators, you can have that many restricted values. How many restricted values do you think you're going to have, for example, 7? 2. What about this? Is that not... What's up? Yeah, actually, if you factor x squared minus 16, it turns out to be a combination of x plus 4 and x minus 4. So there's no... It's not like it produces any extra restricted values. So right now, actually, you can cross that out and replace it with x plus 4, x minus 4. Okay, so you only have 2 restricted values here. From x plus 4, can't be negative 4. Okay. From x minus 4, can't be positive 4. Those are your 2 restricted values. And that's actually going to be sort of a running theme with a lot of these rational equations is if you ever see like 2 different individual factors and then a more complicated quadratic, it'll turn out that the quadratic is actually like the combination of those 2 simpler factors. So for example, on example 10, you might see that the denominator on the right has x squared minus 7x plus 12. Well, that's actually just a combination of these 2 individual factors. If you multiplied x minus 3 and x minus 4, you would get this x squared minus 7x plus 12. But we'll, you know, get to that when we come to it. Okay. So, for this example, what is your least common denominator? Yeah. You need each one of them exactly once. You don't need them more than once, but you do need them at least once. So, x plus 4, because it's in the denominator here, and x minus 4, because it's in the denominator here. And if you have both of them, well, that takes care of this last one. You don't need any extra parts to your LCD for this last one. Okay, so 1 over x plus 4. We're going to multiply that by the least common denominator. And, you know, when least common denominators get kind of, you know, they get to be more, I usually find myself just going like, kind of going like this. Move this over here a little bit. Yeah. This equals 16 over the both of them multiplied by the both of them. Okay, so on the first term, which factor is going to cancel out on the top and bottom? Yeah, only the x plus 4. The x minus 4 will stay. What about the second term? Okay, only the x minus 4, the x plus 4 will stay. What about on the third term after the equal sign? Both of them. Okay, so what we're left with is 1 times x minus 4, which you can just write x minus 4, yeah. We have a plus 1 times x plus 4, so that's just an x plus 4. So if you want, you can put these in parentheses for now. And it equals 16. All right. That's a pretty simple linear equation. In fact, if you try to combine like terms on the left-hand side here, you just get 2x because the minus 4 and the plus 4 will cancel out. So x equals 8 is your proposed solution. Is it either of the restricted values that you found in the beginning? No, so it is good. It is your solution for real. Not restricted.
So you just did the two x's together?
Yeah, it's just x and x. Well, one of them's a -4 and the other one's a +4, so if you combine them, it's a 0. Yeah.
I didn't know if you had the time.
Oh. Let's see. Well, I mean, it's kind of like that. Actually, you know what? 2x -4 +4. And then these just sort of, yeah. Okay, we'll skip 8 and 9. And we'll do 10. So for number 10, what are your two restricted values? Okay, 3 and 3 and 4. Yeah, just straight up 3 and 4. Based on what I told you earlier, yeah. Based on what I told you earlier, and I might have just told you, how do you think this is going to factor? This x squared minus 7x plus 12. Yeah, it's just going to be x minus 3 and x minus 4, the other parts of those denominators that you can see. So you can cross it out and write in that it's going to be x minus 3 and x minus 4. Okay. And not only is it going to be like the combination of the other denominators in the problem, it's also probably going to be like your LCD. So your LCD, in this case, is just this combination of x minus 3 and x minus 4. Okay, so x minus 3, that gets multiplied by your least common denominator of x minus 3 and x minus 4. Okay. Plus 5 over x minus 4, that also gets multiplied by your least common denominator. And equals this whole x squared minus 20 over x minus 3, x minus 4. This also gets multiplied by your least common denominator. Okay. On the first term, the x minus 3 factor on top and bottom will cancel. On the second term, the x minus 4 factor on the top and bottom will cancel. And on the last term after the equal sign, both factors on the bottom will cancel with their corresponding factors on the top. Okay. So that the fractions go away, and what you're left with is three times x minus 4 plus 5 times x minus 3 is equal to x squared minus 20. Now it looks like this is going to be a quadratic equation. But if you go ahead and distribute everything that's in front of those parentheses, that's 3x minus 12 plus 5x minus 15 is equal to x squared minus 20. And if you combine like terms, yeah, it's going to be 8x. 8x minus 27 is equal to x squared minus 20. Now this is looking kind of like a quadratic equation, a little more like now. And so we'll just try to get it to equal 0. I like the fact that there's a positive x squared on the right-hand side, so I'll try to move everything to the right-hand side. Subtract 8x, and I'll also add 27. Okay, that should give me 0 is equal to x squared minus 8x plus 7. Okay, now this is factorable. I want two numbers that multiply to 7 but add up to negative 8. Yeah, negative 7 and negative 1. Okay, so this factors into two factors, x minus 7 and x minus 1. And if if I have it equaling 0 here, what are my two solutions for x then? Yeah, this will give me x equals 7 once I set it equal to 0, and which I guess I can do.
Okay. What'd you do?
At what stage?
Because I know you combine, your like terms. What'd you do after that? With the little red.
Like from here to here?
Yes.
Okay.
Did you just put it all to one side?
Yeah, all to the right side.
Oh.
Here, let me actually
Oh, and then this one. Oh. Okay.
Yeah. And then just add 27 to both sides. Yeah.
Okay. Yeah. Thank you.
X equals x. Damn, what is that? Does it keep happening? Okay, so x minus 7 equals 0 and x minus 1 equals 0. Add 1 to both sides of this. Add 7 to both sides of this. So you get two proposed solutions, because this is a rational equation still, or it was at the very beginning at least. Are either of 7 and 1 your restricted values from the very beginning? No, because your restricted values from the very beginning were like 3 and 4 or something. Yeah. So both of these answers fine? Okay, this rational equation has two solutions. Not restricted. Okay, but that's how these rational equations are going to go. You're going to look for restricted values, you're going to multiply by your least common denominator, and it's going to turn it into a kind of equation that you've seen before. The simpler ones will turn into like linear equations. More complicated ones like this will turn into quadratic equations instead. But, that's what will happen. So the only difference is having to multiply by the least common denominator beforehand to like turn it into a kind of equation you've seen before. And at the end, having to check that the solutions that you get aren't really your real solutions. Check that they're not the restricted values from the very beginning. So it's very important to check for your restricted values in a rational equation like this, because it can be the difference between a solution being your solution and a solution not being your solution, and being like extraneous solution to a problem that really has no solution in the end. Okay, so that is the end of that. we're going to learn about a method of dealing with quadratic equations that you can or don't want to factor. Hopefully everyone likes factoring. But in case you don't, this is a alternative to that. So far, the only way we know to deal with quadratic equations is through factoring, through breaking it up into, like two usually separate factors based on, what numbers multiply to C and add up to B, and it requires quite a bit of number sense, and sometimes you even have to take the number that's in front of the x squared and slide it to the back and divide by that same number later. If you don't want to do that, or if you can't do that, in case some quadratic equations are unfactorable or prime, you can use the quadratic formula. So at this stage, once you know this, you can no longer say that a quadratic equation is prime, because that's not like a reason not to do it anymore. The quadratic formula will still work for, it'll work on any quadratic equation. Doesn't matter if it's prime, doesn't matter if it's got like nice answers or not. It doesn't matter if the answers are imaginary. It'll still work. It'll always work. But it'll especially work on the unfactorable or prime ones. So this method can be used on any equation, but is most useful on the unfactorable ones. Or the ones with imaginary solutions. So I don't want to see, on the homework, anyone say that, a quadratic equation has no real solutions and therefore shouldn't be done. You can find these imaginary solutions. You just have to use the quadratic formula. Yeah. Okay. But here is a quadratic formula. Every semester gets to watch me lose it a little bit more. Okay. So, before you use the quadratic equation, it does have to equal 0. Same as when you're factoring, to find a solution. To find the solutions, it's got to equal 0. It's not going to work if it doesn't equal 0. If it doesn't equal 0, it's worthless. So, quadratic formula, which is what this is, goes x equals, And on the top, negative b plus or minus the square root of b squared minus 4ac. That's all underneath the radical, the b squared minus 4ac. And it's all over 2 times a. There's a song that goes with this. There are probably many songs that go with this. You can look it up on your own time. Okay, so the most important thing is to identify, is first, that the equation equals 0, and 2, to identify the values of a, b, and c. For this quadratic equation right here, first we'll solve by factoring, the usual way. And I'm not going to fish for answers here. It's 7 and 3. Yeah. Which means that the solutions are negative 3 and negative 7. Okay. And then we'll use it. Then we'll solve it by using the quadratic formula. See if we get the same thing.
And that's why you have to do the pyramid. That's how you got to take 7, right?
Yeah, right. Yeah. Right, the two numbers that multiply to 21 but add up to 10, that's 7 and 3. Positive 7 and positive 3. Okay, so first, this equation does equal 0. That's how I was able to factor. That's why factoring worked in the first place. So that's good. What are the values of a, b, and c in this quadratic? Okay, yeah, 1, 10, and 21. A is the first of these. A is whatever is next to the squared term. So a is 1. Yeah, if there's nothing next to the squared term, if it's just a plain x squared, a is 1. But it always is something. B is 10. And C is 21. All these numbers matter. So we're just going to take the quadratic formula. And when you plug these in, make sure to plug these in with parentheses around them. It's just for the best. So x equals negative b. Actually, let me just write the regular formula down here. Okay, so negative b plus or minus the square root of b squared plus 4ac. Make sure that's all under the radical. All over 2a. Okay, so x equals negative b is 10, so there's a negative, and then there's the 10. Plus or minus the square root of b squared, so 10 squared, minus 4 times a is 1, times c, and c is 21. All over 2a. Okay. Now, what I recommend to you is resolve the part under the radical first. And whether you use that, whether you use your calculator to do that or just sort of figure it out in your head, doesn't matter to me. But don't include the radical. Just include what's under the radical. So what is that? 10 squared minus 4 times 1 times 21. 10 squared minus 4 times. Yeah, it should be 16, I believe, because it's going to be 100 minus 84. Yeah. So just what's under the radical, all that stuff under the radical, is 16. Okay, so we've simplified that a little bit. X equals, this is just going to be negative 10 plus or minus the square root of 16 all over 2 times 1 is just 2. Now that doesn't look like it's negative 3 and negative 7, but let's simplify this a little bit. What's the square root of 16? 4. Negative 10 plus or minus 4 over 2. Now this is all made up of numbers. There's no radicals in this anymore. Whatever radicals were there resolve to be whole numbers. So you can actually figure this out. So because of this plus or minus sign, there are sort of two answers here. One of them is negative 10 plus 4 over 2. That is negative 6 over 2 or negative 3. The other answer is negative 10 minus 4 over 2, which is negative 14 over 2, which is negative 7. So ultimately, the same two answers as before, negative 3 and negative 7.
That's what I did.
You might say that right now, but there are some quadratic equations with solutions that, maybe they're factorable, but factoring them is not going to be a good time. I know there are a couple. I'm sure some of these are fine, but eventually you're going to get tired of factoring trinomials, particularly if they have a coefficient in front of the x squared.
That's what the previous homework was trying to do, like train our brain to now that we're doing, quadratic trinomial, because I feel like there was so many ways to get the answer, and I'm like, hey, let's just be now seeing this, you know what I'm saying?
Right.
It's training. That's what I'm like.
Okay. So in example 1. A is 2, B is 3. What is C? Negative 4. Make sure to include that minus sign, or that negative. So just throw that into the quadratic formula. X equals negative b, so negative 3 plus or minus the square root of b squared, and b is, again, it's 3, minus 4 times a, which is 2, times c, which is negative 4. All of that over 2 times a, which is 2. Okay, so that's just negative 3 plus or minus the square root of what number turns out to be under the square root. Yeah, because that's going to be 9 plus 32? Huh. Okay. Did I mess up here? Minus 4ac. Minus 4 times a is 2, and c is negative 4. Yeah, okay, so that'll be 41. And that's particularly nice because 41 is prime. It doesn't have any factors, including square ones, so it is already in the simplest way that it can be written.
So that like we just write it separately because you know what I mean? They made us write it separately.
Oh, like negative 3 over 4 plus or minus, or...
It has to be its own separate operation, so you have to
Oh, okay.
separate the plus and minus.
Right, right. But once you, stick them all into that formula, that's, resolve it as far as you can, there it is. Okay. Can I use the quadratic formula right away on number 2? No, because it doesn't equal 0. Yeah, so you want to make it equal 0. Just subtract 20 from both sides. And you'll have to insert a minus 20 just at the end of the left-hand side. But it can be done. Plus 3x minus 20 equals 0. And now you're ready for the quadratic formula. Of course, what are A, B, and C? Mm-hmm. Yeah. C, negative 20. Just stick those in the same places you stuck A, B, and C last time. X equals negative B, that's negative 3, plus or minus square root of B squared, so 3 squared, minus 4 times A is just 1, times C is negative 20. And that's all over 2A, so 2 times 1. So what did you guys get for what's under the square root? 89? Okay, cool. So the square root of 89, the square root's still there. It's just, like the reason you don't want the square root is because if you do that, then like it's not going to mean anything to you. Like it's not going to mean like 9.43398 is not as meaningful as the square root of 89. So you don't actually want to evaluate. You don't want to include the square root when you evaluate in the calculator. You just want to say, I know what number's under the square root. It's 89. And then just place that over 2. 89 is, I'm pretty sure it's prime. It definitely doesn't have any square factors. So those are your two solutions. And there are two solutions because of that plus or minus. You can write it like this. You're also free to write it like, x equals negative 3, like negative 3 plus, like one version of the answer with a plus, and a separate answer, or a separate, answer with a minus. If you really want to convince yourself it's two separate answers. Okay, minus 2x. Let's see. X. Yeah, this will be fine. Okay. Subtract 2x to get it to equal 0. Okay. This one's an interesting one because in this case, B is a negative finally. A is 1. B is negative 2. And C is negative 1. So x equals negative b, and b is already negative 2, so ultimately what will this negative of negative 2 become? A positive 2. Plus or minus the square root of, again, b squared, and this is part of why it's important to use parentheses when you're substituting these in. With this b squared, negative 2 squared is going to become positive 4. And that's only going to work if you make sure to wrap your negative 2 in parentheses before squaring it. Times 4ac. So a is 1, c is negative 1. And that's all over 2 times a, so 2 times 1. Okay, so that's going to be positive 2 plus or minus the square root of something. 4 plus 4, 8. square root of 8 all over 2. This is not done because in this case, unlike the previous case with like the square root of 41 and the square root of 89, the square root of 8 can be simplified. What square number is a factor of 8? 4. So we'll split it up into the square root of 4, and then what's the other factor? Gotta be then 2. The square root of 4 resolves into the whole number 2. The square root of 2 just stays the square root of 2. Okay. So this is 2 plus or minus 2 square roots of 2 all over 2. You can, each one of these terms is divisible by 2, or you can split it up and simplify the fractions individually, but either way, you're actually going to end up with the same thing. You're going to end up with 1 plus or minus a single square root of 2. You can write 1 square root of 2, or you can just write square root of 2. But that's what happens if your square root can be simplified. If I move that, it'll be 4 minus 6. 4 minus 4 times 6 times negative 1. So that'll still be, yeah. We can skip 4. We can skip.
There wouldn't be an issue with that, with the negative.
I don't think there would be a negative number being under the square root once you moved everything over. Because that is what I was thinking of though. Because just if I do just the square root part, that's going to be negative 2 squared minus 4 times 6 times negative 1. And so that's going to be 4 plus 24. Yeah. Yeah, I was actually I was looking for one that had a negative number underneath. Alright. So 16 minus 4. Okay, yeah. Example 5 is a good one. Okay. A is 1, B is negative 4, and C is positive 8, or just 8. First of all, does it equal 0? Yeah. Okay, so that's good. Well, not only good, but absolutely necessary. So negative B, and B is negative 4. So negative 4, which is eventually going to become, resolve into a positive 4. But right now we'll just write it as negative 4. Plus the square root of b squared, so negative 4, in parentheses, squared, minus 4 times a, which is 1, times c, which is 8. All over 2a. Okay, so as I said, that negative 4 will become a positive 4, plus or minus, what's underneath the square root? Negative 16. All over 2. Now you don't have to think, you won't have to think too hard about this. So what does that negative underneath the radical mean that there's going to be when you simplify it? In I. And other than that negative, you got the square root of 16. What is the square root of 16? Just the whole number 4. So the square root of negative 16 is 4i, yeah. 4 plus or minus 4i. Just the whole number 4 and an I. All over 2. You can simplify this by dividing each thing by 2, or by, again, splitting it up and simplifying each part individually. Yeah, so, it's possible to find out some imaginary solutions this way. with the quadratic equation that you could not find by factoring. So 2 plus or minus 2i, basically. Okay. That is a good one. Okay. B squared. Yeah. Okay, we'll do example 6. And while, I might normally want to move this to the right-hand side so that it can get a positive 3x squared, but with the quadratic equation, it actually doesn't matter. I'm actually just going to do what takes the least number of steps, which is to subtract 6x from both sides. So that gives me negative 3x squared minus 6x minus 5 equals 0. And I'm going to identify a, b, and c from there. A is negative 3, b is negative 6, c is negative 5. If you instead want to move everything else to the right-hand side, that'll still work. It's just that a, b, and c will be positive instead, but you'll still get the same answers in the end. X equals negative b, so negative 6, plus or minus the square root of b, which is negative 6, squared, minus 4 times a times c. So 4 times a times c. So what number is underneath the square root? Yeah, right. The negative 6, if you square it, it will be positive 36, and then multiplying all these together is going to have you take that 36 and subtract 60, which gives you negative 24 underneath the radical. Okay, so 6 plus or minus the square root of negative 24 all over negative 6. Okay, now let's just take a look at this negative square root of negative 24 here. Because there's this negative underneath the square root, what do we know that the simplified version will have in it? An I. And other than that, 24, what square number has, what square number is a factor of 24? 4. And then the other one will have to be 6. So the square root of 4, square root of 6, and then an I from the negative sign that's like underneath there. The only one of these that really changes is square root of 4, which is 2. So it's 2 square root of 6 I. So 6 plus 2 square root of 6 I all over, plus or minus, all over negative 6. Okay. And you can simplify this by, dividing by 2. Each one of these things is divisible by 2, not by 6. Okay. But this should come out to 3 plus or minus, these are division symbols. Okay. 3 plus or minus a single square root of 6 times I. I might want to try to divide by 6, but between 6, 2, and this negative 6 on the bottom, the most I can divide by, like, the greatest common factor basically is 2. Yeah. It's this 2 that I'm trying to get rid, or like trying to simplify, that's really limiting me. Yeah. And then just a negative 3 on the bottom, that's fine. Yeah, that should be it.